You know that feeling when something is technically perfect, but in reality it's completely useless? Well, we're about to dive into a story just like that. It's about a piece of AI-generated code that was 100% correct, but at the same time 100% wrong. And it reveals a huge blind spot in how we're all learning to use these powerful new tools.
So picture this. You've got Timothy, a junior developer, and he's practically buzzing with excitement. He goes up to his senior colleague, Margaret, and announces he's finally squashed this really tricky user authentication bug. You know, the one that's been gathering dust in the backlog for weeks? And he did it all with a little help from the AI coding assistant Claude code. And look, on the surface, this is a huge win, right? The code passed all its tests, it got deployed, mission accomplished. But here's the twist. What if that so-called perfect fix was about to make the user's life even more frustrating?
This is where Margaret, the senior engineer, comes in. She doesn't just skim the code. Nope. She reads every single line. And that's when she spots it. It's not a syntax error, not a bug in the traditional sense, but a flaw in the logic. It's this super subtle but critical mistake that both Timothy's tests and the AI completely flew past.
And this is the absolute heart of the issue. Margaret points out that the session expiry was hard-coded to 24 hours from the moment of login. Now just think about that for a second. A user could be deep in their work, right in the middle of something important, and then poof, they get logged out. Why? Just because the 24-hour clock ran out. The code wasn't broken, it just didn't do what anyone actually needed it to do.
Okay, so let's break this down because this is where it gets crystal clear. The AI built a fixed expiry system, meaning the timer starts when you log in, and 24 hours later, you're out. Period. But what the users actually needed was a sliding expiry system, where every time you click or type, that 24-hour clock resets. So as long as you're active, you stay logged in. It's a perfect illustration of code that works versus code that's actually right.
And this whole thing points to a much bigger truth about working with AI. See, Timothy asked Claude to fix a bug with session tokens, and it did. It did exactly that, cleanly and correctly. The problem was he never specified the behavior he actually needed. So the AI did what AIs do. It made a logical assumption. It just so happened that its assumption created a terrible user experience.
Margaret's insight here is so crucial. When an AI like Claude gives you this really confident-looking block of code, it's basically saying, hey, the syntax is correct and the logic holds together. What it's not saying is, I completely understand the real-world needs of your users. That part, that's still our job.
You know, it was actually Timothy himself who came up with the perfect analogy for his mistake. He said it was like getting flawless, turn-by-turn directions to the wrong address. The AI gave him a perfect journey, but he'd accidentally pointed it at the wrong destination to begin with. The trip was smooth, but the arrival was a complete failure. So, to help Timothy avoid this kind of thing in the future, Margaret lays out a simple framework. She explains that when AI coding assistants get it wrong, it's usually in one of three pretty predictable ways. And if you know what to look for, you can catch these errors before they cause any trouble.
She breaks it down for him into three common failure modes that you absolutely have to watch out for.
All right, they are solving the wrong problem, giving an outdated answer, and the weirdest one of them all, the plausible fabrication. So yeah, let's dig into each of these.
First up, the wrong problem. This is Timothy's story, right to the letter. The code is technically correct, but it's functionally incomplete because the prompt wasn't specific enough. This is honestly the most common and probably the most dangerous one, because on the surface, everything looks perfectly fine. The code works, it just doesn't solve the real problem.
Second, we have the outdated answer. And this makes total sense, right? An AI's knowledge has a cutoff date, so it might suggest a security practice that's now considered unsafe, or use a function from a library that's been deprecated for years. For anything that evolves quickly, like security or a popular API, you have to verify its suggestions against the current documentation.
And third, the plausible fabrication. This is where the AI, well, it just makes stuff up. Seriously. It'll invent a function name or a configuration setting that sounds perfectly logical, looks completely real, but it simply does not exist. And it will present this little hallucination to you with complete and total confidence.
So how on earth do you catch a fabrication? Well, it almost always breaks the second you try to run it. You'll get an error like function not found, and Margaret's advice here is golden. When you see that, don't just assume you made a typo. you have to stop and consider the very real possibility that the AI literally invented a piece of the solution out of thin air.
So, look, the takeaway here is not to stop using these AI tools. They're incredibly powerful. The real solution is to change how we think before we even start using them. It's about building a whole new discipline of review.
And this leads to a pretty fundamental shift in how we review code. Most of us are trained to check for technical correctness. Does it run? Are there errors? Is the logic sound? But with AI assistance, we have to add this whole other layer, reviewing for behavioral completeness. We have to ask, okay, great, it runs, but does it actually do what the user needs it to do?
And this brings us to the single most important habit you can develop. Before you even write your prompt for the AI, just take 30 seconds. Write down the real requirements. Seriously, just a few bullet points. If Timothy had just written down, "Session should expire based on inactivity," he would have caught his own mistake instantly.
Ultimately, this whole experience taught Timothy a lesson you just can't find in any documentation. He now understands that crucial difference between code that just works and code that is actually right. And for any of us using AI today, knowing that distinction is pretty much half the battle.
It's just like Margaret says, the responsibility isn't on the tool, it's on the person using it. The real skill we need to develop now is learning to ask questions that are so complete and so well-defined that even a technically correct answer can't possibly mislead you. It all comes down to the quality of your prompt.
And that leaves us with a final thought to take back to our own work. The next time you finish a task, ask yourself this one question. Is the code I just wrote simply working, or is it truly right for the people who are actually going to use it?